The InBody Evaluation Results Sheet goes beyond merely displaying your body composition values. This result sheet offers a comprehensive analysis by comparing your data with a reference population, providing average and standard deviation graphs for each parameter based on age and gender. This detailed comparative evaluation helps you to plan your health and fitness goals more effectively. The evaluation result sheet includes 20 different evaluation graphs, 4 parameters to be displayed on the result sheet, which you can choose based on your practice. The first evaluation is based on your T-score and Z-score, which compares your current body composition data to the population's averages and standard deviation values for your age. Let's first understand what T-score, Z-score, and standard deviations are. The T-score represents the deviation of body composition from the mean of a reference population of healthy young adults. Meanwhile, the Z-score represents the deviation of body composition from the mean of a reference population of people of the same age. Both information are expressed in standard deviation units, indicating how close your current data is to the reference population. If your T-score or Z-score is closer to 0 in the standard deviation graph, it means your current data is near to the average population data. A positive sign means your data is higher than the average population, while a negative sign means your data is lower. More specifically, if your T-score or Z-score is between -1 and 1, you are within the 68% of the population. If your T-score or Z-score is between 1 to 2, you are roughly in the top 14% of the population. If your T-score or Z-score is between 2 and 3, you are in the top 2% of the population. Conversely, if your T-score or Z-score is between -1 and -2, you are roughly in the bottom 14% of the population. If your T-score or Z-score is between -2 and -3, you are in the bottom 2% of the population. Now that we have understand what T-score, Z-score, and standard deviations are, let's learn how to interpret these scores and graphs effectively. Let's take a look at this evaluation graph for whole body face angle. The first thing to do is check your face angle at your age. For this person, the face angle is 6.5 at the age of 50. Now, let's check the T-score, which is 0.1. Since the T-score falls within the average range of -1 to 1, this indicates that the face angle is almost similar to that of the young adult population. This is great because it means that Mrs. J's face angle is nearly the same as young adults. Next, we check the Z-score, which is 1.2. Since the Z-score is in the range of 1 to 2, the face angle is considered to be roughly in the top 14% of the same age adult population, indicating a better face angle than those of the same age. Overall, Mrs. J's face angle is almost similar to young adults, but it is higher than adults of the same age group. The next type of evaluation is the percentile graph, which involves understanding the relative precision of a data point within a data set expressed as a percentile. The 50 percentile is considered the median value of respective body composition when compared to the population. Let's take a look at this percentile evaluation graph for whole body face angle. As we can see, this person's face angle is plotted between the 50 and 75 percentile. This indicates that the face angle is similar to or better than 25% of the population. The higher your percentile, the more people you surpass in the population. However, note that a higher percentile doesn't always mean a better result. If the percentile is higher for parameters such as whole body face angle, skeletal muscle mass index, or body cell mass, it indicates a better result. On the other hand, if the percentile is higher for parameters such as percent body fat, visceral fat area, or whole body ECW ratio, a higher percentile actually indicates a worse result. Moreover, the next evaluation graph is the muscle nutrition evaluation graph that illustrates how your body conditions vary based on two key parameters, the skeletal muscle mass index and ECW ratio. Understanding this graph involves identifying which quadrant your current data falls into. If your data is situated within the first quadrant, indicating high SMI and normal ECW ratio, it signifies optimal conditions for both muscle mass and body water. This suggests well-developed muscles and proper body water levels, reflecting overall good body health. In contrast, landing in the second quadrant signals high SMI but high ECW ratio. While high muscle mass appears positive initially, the elevated ECW ratio might indicate overhydration rather than genuine muscle development. If you find your data in the third quadrant, it suggests low SMI but normal ECW ratio. Despite balanced body water levels, the insufficient muscle mass underscores the need for targeted interventions to enhance muscle development. However, if your data falls into the fourth quadrant, indicating low SMI and high ECW ratio, it points to both low muscle mass and poor muscle quality. This combination reflects the most concerning scenario, requiring immediate attention to address muscle deficiencies and overall health. In conclusion, the InBody Evaluation Results Sheet offers a comprehensive and objective analysis of body composition, surpassing mere understanding of individual data with the reference population. Ultimately, by leveraging this objective analysis, individuals can tailor their fitness and nutrition strategies more effectively, striving towards achieving and maintaining an ideal body composition.